Let's go ahead and take a look at externalities. Remember that externalities arise when an action or transaction affects a third party who is not involved in the activity or transaction. So they're essentially going to be a neutral third party who is going to be affected, either benefiting or is going to be harmed by something that you do. They are not privy to your action. They are just going to be an innocent bystander. A positive externality produces benefits to others, while the negative externality is going to produce some type of cost to others. With these externalities, these are going to make up our first market failure, and we will never be able to reach the socially optimum level of goods or services, because remember that we as individuals are very selfish. So when we buy something, when we do something, we don't care about other people. We're not thinking about the harm that we put on third parties. We're not thinking about the benefits that we put on third parties. We're only caring about ourselves. However, in order for us to reach the true sort of socially optimum level, we actually have to take into account third parties. What type of harm and what type of benefits are actually accruing to them. So if we have a good or if we have an action that produces some type of externality, this is why we will never reach the socially optimum level, because by ourselves, if we leave ourselves to our own devices, or firms or companies to their own devices, they will never take into account the third parties. So let's go ahead and focus in on the negative externalities first and see exactly what type of analysis can develop from this. So why can we go ahead and reach the highest amount of welfare and efficiency when we actually take into account these externalities? So as we said, let's go ahead and focus in on the negative externalities first, and a few examples of negative externalities just to refresh your memory. Hosting a loud house party creates a negative externality, which is going to be a third-party cost to your neighbors who prefer it to be quiet. Other examples that we brought up were, of course, going to be pollution, driving on Miami's roadways, farting, not wearing deodorant. These are all actions that you do yourselves. You don't really care about third parties, but they are going to be generating some type of harm to innocent bystanders. So in order to segue us into the analysis that we need to do, we of course take a look at some type of supply and demand analysis. We have supply, we have demand, and we need to go ahead and introduce a few specific numbers. So let's go ahead and do that, and also a few concepts as well. So here I've drawn up the graph that you just saw on the slide right here, and we're going to introduce a few different things right here. So we have our very first supply curve, which is known as SP right here, which represents MPC, or the marginal private cost. So MPC, which equals the marginal private cost. Marginal private cost. Private cost. And this MPC, this SP right here, the marginal private cost, is a typical supply curve that we have thinking about throughout this entire semester. It's basically the supply curve of the firms, and this is just saying that, hey, we're not taking into account any cost on third parties at all. It is the manufacturer's or the supplier's marginal private cost of production, exactly how much it costs them to produce this particular good. So just if you need that for notation, supply in this instance, SP, represents the manufacturer's marginal private cost of production. Marginal private cost of production. So essentially, we're just leaving the market to its own devices. It ignores the external costs imposed on others. So ignores the external cost imposed on others. And if we ignore the external costs imposed on others, we get the typical equilibrium here at point A. So at point A, we have the equilibrium price equals to $6, and equilibrium quantity, let's go ahead and introduce a quantity right here, say equal to 30 units. So here, bring this all the way down. Let's suppose that this is equal to 30 units. So something like point A is going to be known as our market equilibrium. Market equilibrium. And that is just the equilibrium that we have been dealing with for a very, very long time. So ignoring these costs, we can go ahead and say that this is our market equilibrium. Ignoring these costs, market equilibrium, or we can just say equilibrium in general, equilibrium is at point A. And hey, point A is our market equilibrium. So knowing all of this, the very first question that we can go ahead and ask is, what is the amount of efficiency and welfare that we have at market equilibrium? So far, we're just detailing a few of the very specific things that we already know how to do from the previous chapters. So first question is, how much consumer surplus, producer surplus, and total surplus is there going to be at that market equilibrium? So first of all, consumer surplus, just as a refresher, it's the area above the price but constrained by the demand curve. So the big triangle that we see at the top right here, very, very easy because we are working at the market equilibrium right here. So it is a triangle, 1/2 times the base times the height. Just find the distances and you're good to go. The height is going to be 9 minus 6, and the base is going to be 30 minus 0. So once again, it's just a triangle. Use the formula for a triangle. 1/2 times the height, 9 minus 6, times the base, 30 minus 0. And simplifying this as much as you can, we get $45 worth of consumer surplus. We can do the same thing in terms of producer surplus. Producer surplus is the area below the price but above the supply curve. So here, this triangle, the bottom triangle right here, the height is 6 minus 3. The base is 30 minus 0. It is a triangle once again. So producer surplus, 1/2 times 6 minus 3 times 30 minus 0. We have the same base right here, and we get $45 worth of producer surplus. Final thing that we can go ahead and do is add both of these up together in order to get total surplus. So 45 plus 45 will give us $90 worth of total surplus, or the area of this big entire triangle right here. So we already know how to do this, so nothing new in this regard. However, let's go ahead and introduce a little bit more complexity now. Suppose now that when the firm is actually going to be producing this particular good right here, we introduce some type of pollution cost. So for every single unit that the firm is going to produce, it imposes some type of harm or negative externality on everybody within the economy. So that does impose a very real cost on everybody within the entire economy. So now let's go ahead and account for that. Let's go ahead and see exactly what happens to our total surplus when we introduce these pollution costs. So now let's go ahead and assume that for every unit produced, pollution costs are equal to $2. So here, introduce this new change right here. Now assume that for every unit produced, pollution costs are equal to $2. Pollution costs are equal to $2. So for every unit that this firm is going to produce, we incur $2 worth of pollution cost. So at point A, how many units are you producing? We're producing 30 units, so therefore $60 in pollution is going to be generating. And this is going to segue us into the second question that can be asked from this setup right here. So question number 2 is, hey, we noticed that at point A, we have 30 units being produced. So at point A, 30 units are produced. And when 30 units are produced, that tells us that if we're producing 30 units, we have $2 of pollution cost for each of these units. We have $60 of pollution is generated. $60 in pollution costs are generated. So here, we're still assuming that the firm and corporation isn't taking into account the harm it's imposing on the third parties. So when we take a look at point A, our total surplus was equal to $90, but now we're generating some type of pollution which harms you and I, and that's $60 worth of pollution, and that harms people within the entire economy or within the entire marketplace. So when we account for these costs, how much is our total surplus going to be now? So when we account for these costs, accounting for these costs, we have 90 minus $60, so only $30 in welfare. $30 in welfare or surplus is going to be generated. So while at point A, well, we'll just say while producing at point A, at that market equilibrium. So before we had $90 worth of total surplus, but when we produce these, we now have some type of pollution cost, and when we subtract out the cost that's being imposed on the economy, we only have $30 worth of total welfare or surplus within the entire economy. So the question now becomes, can we do something better than this? And the answer is, we can do something better if we actually make the firm feel the cost or make the feel the harm that they're imposing on the third party, so people like you and I. And that's exactly where we need to incorporate the external cost into our analysis. So this is going to be the third question that can be asked from this. So here we need to incorporate external costs or the externalities into the analysis. So can we do something better than this $30 worth of welfare? And the answer is going to be yes. In point 3 right here, when we actually incorporate the external cost, when we make the firms and corporations feel the cost of the pollution itself, then we can actually do better than that. And how can we do that? We're going to introduce a new supply curve, which is known as the marginal social cost. So here we introduce the true marginal cost of production. And the true marginal cost is essentially the firms and corporations that are supplying this good. They're now going to feel the impacts of the pollution that they put on the third parties. So this includes the externalities, which includes the externalities. And this is going to introduce a new supply curve, which is supply SS, or the MSC. So MSC, which is the marginal social cost. So marginal social cost. And when we do this, when we insert this new supply curve, we're going to go ahead and shift our supply curve over to the left by the amount of pollution that is generated. So for every single unit, we notice that we have $2 worth of pollution being generated. So in order for us to see the true marginal social cost, we shift our supply curve up by the amount of pollution. So we started off at the axis at $3. That tells us that our new supply curve, this marginal social cost, is going to be shifted by 2 units. So we start off at 5, and that's exactly where the new supply curve comes in, this SS. So SS, remember, that is our marginal social cost. MSC, the marginal social cost. So we're making these firms and corporations actually feel the harm that they're imposing with their production. And when we do that, we notice that a new equilibrium is going to emerge, and that is the new intersection right here at point B, where we notice that we have a higher price for the good and a lower quantity in equilibrium. Say this is going to be 20 units here. And point B is going to be our new equilibrium, which is the social optimum. And the social optimum is exactly where we want to go ahead and be operating at, because that's where we're going to be generating the most amount of efficiency or welfare when we actually have some type of pollution. So how much welfare and efficiency are we generating? Well, we can go ahead and find the total surplus. So this big triangle right here, we have consumer surplus, producer surplus. We can just go ahead and combine the two of them together. We have a triangle right here. So the distance, the area of the triangle, is 9 minus 5, and it's going to be 20 minus 0 for the base and height. So as we compare the total surplus right here, what should emerge? So the total surplus at the social optimum, Using the numbers that I just gave to you in terms of that triangle, we have 1/2 times the height, which is 9 minus 5, times the base, which is 20 minus 0, which gives us $40 worth of total surplus or efficiency. And we notice that, yes, this is better and higher than what we had in point number 2 right here, where we only have $30 in welfare. So if we actually can make the firms and corporations accountable for the costs that they're going to be imposing on the third parties, then we can actually do better as a whole in society when we're operating at the social optimum itself. So as we can see from the setup that we have right here, we notice that, hey, if we leave the market to its own devices, we notice that it's going to be at a very low price with a very high quantity. So at point A, that market equilibrium. However, if we introduce pollution into the mix, we notice that total welfare and efficiency is going to go down because the firms and corporations are not taking into account the cost that they're imposing on the third parties. So in order for us to do better, we need to introduce the MSC, or the marginal social cost, and make the firms and corporations accountable for the harm that they're putting out into the economy in the marketplace. And that's exactly where we reach point B, where we have the social optimum, albeit it's going to be at a higher price and a lower quantity for this good. So this tells us that whenever negative externalities are present, an unregulated market is always going to be operating at point A, but that's not going to be the best thing for the economy, because we notice that it's going to be producing too much of the good at too low of a price. So compare point A and point B right here. At point A, the price is very low and there's a lot of quantity, so the market says that, hey, we really don't care about you people at all. However, in order to make firms accountable, we should be operating at point B at a higher price and lower quantity in order to ensure that the total amount of welfare and efficiency is going to be maximized. So the last thing that we can make a note of is exactly that within these negative externalities. So whenever negative externalities are present, when negative externalities are present, when we have an unregulated market, regulated market will produce too much of the good, at too low of a price, So here, with negative externalities, an unregulated market will produce too much of a good at too low of a price. So essentially, we're comparing point A versus point B, the market optimum versus the social optimum. And in order for us to reach the social optimum, we need to go ahead and raise the price. And basically, by raising the price, we're making the firms feel the cost of the pollution that they're imposing on third parties. And in doing so, will help to reduce the quantity right here, also helping to reduce pollution as well. So 3 questions that we can ask on the negative externality side. So what exactly is going to be the total welfare or efficiency at point A with an unregulated market with no pollution? What is going to be the total welfare and efficiency at point A when we introduce some type of pollution at that market optimum? And then finally, number 3, what is going to be the social optimum? What is the welfare and efficiency there, and how exactly do they compare to the market equilibrium? So a little bit more of a longer concept and a little bit of a more denser topic, but this will be easier to see when we take a look at the demand side when we bring in the positive externality. So just segueing us and laying down the foundations for that particular subset. I'll see you guys in that video.